Yeah, this is our GPS tracker presentation. My name is Luis. I was the development lead, and Justin was the team lead and also mechatronics since we lost someone halfway through the semester. Okay, so what's it for? This GPS tracker will log GPS coordinates onto an SD card. Those coordinates can then be used with Google Earth Pro to see where the device has been. This project was initially supposed to be a real-time GPS tracker that we could use in a car to see where it was. Some of the plan upgrades that we would like to implement to make this even better would be a GSM module that could be pinged to get the real-time location of the car, and then also add a module that would help detect the speed and direction the vehicle was heading real time. Some of the parts that we used for this GPS tracker were the Arduino Uno, the Neo 6M GPS module, the SD card module, and then a solar-powered battery pack. Here's our wire diagram. It shows how each of these modules were connected to the Arduino, and uh, lets you see how many wires were used for each of these. And here's our block diagram with our GPS code inside. So we have the solar battery pack that connects to the Arduino that powers the GPS module and the SD card module. The GPS module connects to satellites that will get the GPS location, and that information is stored onto the SD card. The information or the code that's used to get this information is seen here. So we used setup to set up all the code necessary for the modules to work. Then we have the loop function, which will call the encode GPS data, which we'll talk more about later. And then that will also, the loop function will also call the calculate location. And this is, since it is in the loop, it will keep going approximately every 4 seconds. It will get those coordinates depending on where the device is located. So here's some of the code inside the loop function. So we have the encode GPS data function, which has a delay of 1 second, as you can see there. And then we have the lat val and longitude val, which we use the GPS mod library, tiny GPS, and we'll get the location using that function. We have the SD library, which we use to log the data. It's stored onto GPS data.txt. So we write that file, and then we use the calculate location, which is used for converting the information that's parsed on the GPS coordinate string here that we can see in encode GPS data. The SD card receives the information from the GPS module. It's printed onto it, and you can see that there. That's inside the loop. And then we have the calculate location function, which, as I said, just converts GPS data into degree, minute, seconds form. And here we'll have our video presentation.
So this is the device fully assembled with the power bank, the Arduino Uno, the GPS module, and the SD card reader. This is everything wired up. When it is working and when we take it outside, we will put the SD card into it, and we'll have a blue indicator light that shows that the GPS is communicating with the satellite and receiving data. So that's what the hardware looks like for this project. So we are in the car right now. We have the GPS module hooked up, and as you can see by that blue light, it is receiving a signal. So we will drive around and then go back inside and upload the SD card coordinate to the computer. Hey everyone, so we are back inside and I have just loaded the SD card into my computer, and you can see we have the GPS data file here. I'm going to go ahead and open that, and as you see we have these zeros right here at the beginning, and that's just for the time it takes for the GPS to initialize and actually get signal from the satellite and start receiving data. So what we can do is, since we don't care about seeing any zeros in our chart or in our Google Earth plot, we can go ahead and delete those. And as you can see, we have the rest of these data points. So we will go ahead and take this file, and what we'll do is we will load up Google Earth Pro, and we will go ahead and import this file here. And we'll import, yes, we'll take the GPS data file, go ahead and open it up. Check that. And then we want to confirm that the latitude and longitude are right. So this longitude needs to get switched to this number. And then we can go ahead and finish with that. You don't need to add any style templates. And we'll go ahead and make sure to include that on the graph. And as you can see here, these are the GPS coordinates. So this is when we went and took the GPS outside. We went and put it in the car, and then we took the car and we went for a little drive around part of campus here. And as you can see, it plotted all the points. And then some of these points are also us taking it out of the car and coming back inside. And as you can see, once we entered the building here, it lost signal. So it does have limitations with objects obstructing it, but that is how our GPS locator works. Hi, everyone. Welcome back. So this is the victory code. So now that you've just seen our project in action, some of the victories that we saw starting off with the code, it was definitely easy to understand, and it is easy to understand for someone without a coding background. They could go in there and get a basic understanding of what's happening, as well as the fact that it displays GPS coordinates in an understandable format, very simple latitude, comma, longitude, which makes it easy for anyone to be able to take those, whether you have the Google Earth program like we did, where it will pull it and display it, or if you wanted to enter those in manually somewhere. Some more victories that we had concerning the GPS module. It was definitely a lot easier to implement than the Logger Shield was. The Neo 6M GPS module was compatible with our code already, so we didn't have to really change anything from that stance. And the tiny GPS library that we used to get the GPS data from the satellites was able to fix all our issues and gather that data without us having to jump through any extra hoops or have any problems. Another thing, like I said, GPS coordinates were saved to the SD card that could be plotted. The format that we had them in was easily grabbable by Google Earth when we imported the file. And the coordinates are parsed into simple latitude and longitude coordinates. And then the SD file, like I said, could be entered into Google Earth to plot the tracking map, which was really nice. So that was a huge success overall. Other successes were that we were able to finish our project even after losing a team member early on in the semester. And we were able to redefine our project objective after a few weeks of troubleshooting and able to complete a project very similar to what we set out to do in the beginning. But we do also have room for improvement, which I think is also a victory because there's always room to grow. Some of the challenges and shortcomings we faced, definitely the HC12 was a big challenge that we faced, considering it didn't work with the Arduino Uno because it used the same baud rate as our serial port, and the Arduino Uno does not allow for the use of the serial port to read and write, or in this case, simultaneously receiving and transmitting. So, uh, again, another challenge that we did occur, and I mentioned this earlier, was that we did lose a team member less than halfway through the semester, and having two people made it difficult for our original design. So we had to improvise and change. We also could not get the GPS logger shield to work. That was partly due to the fact that we didn't fully understand how it worked, and also due to the fact that there were not a ton of resources or information that we could find about the device, how it worked. It seemed that we could find very little on it or examples of others implementing it. So that again was part of why we did not have enough understanding of how it worked. In conclusion, we definitely learned how to program a GPS in Arduino, and overall more coding of an Arduino and how it works. We definitely realize it is important to research components before purchasing them, just to make sure that they are all compatible with one another and that they don't interfere with or block one another's functions. Definitely realize that issues will arise no matter what, so plan for this in advance. And every microcontroller has advantages and disadvantages, and it's important to recognize those beforehand. Like we realized a little late in the game that the Arduino Uno couldn't read and write at the same baud rate, but we did do a little more research and realize that an Arduino Mega would have allowed this. Some improvements that we know could go into future design would be implementing a transmitter and receiver for real-time tracking anywhere. And that could either be by switching out the Arduino Uno or possibly finding a way to use cell phones, and minimizing the design so that it was more portable and a little easier to carry around or attach to a car in this case. So that is the end of our presentation. Thank you so much for watching.